Hello everyone, this week we're going to talk about joins. Joins is one of my favorite topics in this course. It can be a little bit of fun doing joins. It's interesting to think about how things connect to one another. And of course joins is one of the things about these databases. They're relational databases, meaning that all these tables have relationships to each other. So we can use joins to connect these tables together when we're trying to get more meaningful information from our databases. I would say that understanding how to do joins is really important for database management and for database scripting, which we learn in this course. So the first thing we need to do is we have to run a SQL script to build our database for this unit, if you want to follow along with the book. So I'm going to go ahead and upload a script. So I downloaded mine already, so let me go grab it. Oops, it's not that one. There we are, data files, week 9. And again, these are all in Blackboard, so you can just do these in Blackboard. So I'm just going to put unit 9, or chapter 9, upload my script, and then run it. We've done this before, so this is nothing new. I just have to run this in order to do the exercises. All right, so it's running the script. Let's give it a second. So I'm going to run it now. All right, so my script has run, so I'm going to go to my object browser, and we'll take a look at some of the tables that we have. And it's really no different than most of the other units. We should have similar tables. Let's see, so we have employees, publisher 2, publisher 3, and warehouses. So let's take a look. Okay, so I'm just waiting. Oh, there we go. So the list came up. So we have a bunch of tables here. So first, let's take a look at this. If I look at the books table, we have some columns in the books tables. For example, I've got a title for the book, right? And if I look at, let's take another example here. So publisher, so we have a title for a book, and then there's a pub ID right here. And then if I look at my publishers, let's wait for this to load. There we go. So now I have a name of the publisher, right? So I have a title of a book, I have a name of a publisher. We know that this is the foreign key. We've learned about foreign keys already. But let's go to the SQL commands. Now let's just type a simple example here. So I've got two tables, and I want to show data from both of those tables, right? So if I try to do a select for, I know I want the title from my books table. I want the name from my publisher table. And then I'm just going to type from, let's see, it's books and publisher, right? So I'm just saying, give me the title from books, get me the name from publisher. I click run, and let's see what happens. And I get invalid SQL statement because I highlighted that right there. You can't highlight, obviously, or else it just runs what you tried to highlight. There we go. Okay, so if we look at this list, take a look at what it did here. For every single book, it showed the name of every single publisher. This is called a Cartesian join, and if you do nothing else, if all you do is tell Oracle to select data from a couple different tables, it's just going to combine all the records from table 1 with all of the records from table number 2. And if you had a third table in here, for example, if I added warehouse, right? So now I'm selecting from 3 tables, and my warehouses probably have a location, I think. Let's see if that works. All right, so now it's combining everything, right? So for every single location, it's showing all combinations of publishers and books. Now this is completely meaningless, right? This doesn't really, and you can see down here we have 210 rows, right? That's an awful lot. This is completely meaningless though, right? Because there's no way that all these books are at all these different locations, right? That doesn't make any sense. We know that each one of these books is not published by every single publisher, right? That clearly is not the case. So what we probably actually want to do, let me get rid of warehouse here. I just wanted to show you an example that it just multiplies everything. And by the way, if you were taking a test and I said, what is a Cartesian join? You would say it multiplies all the records from table 1 times the number of records on table 2 and outputs all of those records because it does every possible combination of those records. So you would take, let's say you had 10 rows in table 1 and you had 10 rows in table 2, that means that your result set is going to be 100 rows because you're going to get the combination of both of those tables multiplied by times each other, right? So for record 1 in table 1, you get all 10 rows in table 2. Then for record 2, you get all 10 in table 2. Then for record 3, you get all 10 in table 2, and so forth. So that's obviously not what we want to do, right? And by the way, another way you could write this, so this is the old-fashioned way of doing this, but I could also type cross join, right? So another term for that, and you'll see that in your textbook, it's called a cross join. So a cross join does exactly the same thing. It just joins everything to everything. It's really hard for me to give you an example in the real world of where you would want to use this. I know I've used cross joins or Cartesian join a few times in my career. I've been doing this for almost 20 years, and I can only recall maybe a handful of times that I've needed to use a cross join, so they're not very common, or a Cartesian join. What's more common is that you're going to connect these tables with some kind of a parameter, right? So one way you can do this is sort of the old-fashioned way to do it. It does work in Oracle. This won't work in all database engines, but this will certainly work in Oracle. So you do a where clause. So for example, where books.pubid, because I know that pubid is in the books table. That's a foreign key to publisher.pubid. Oops. Okay. So I can connect them this way, right? So let me go ahead and run that. And I should get much more meaningful data this time. I only have 14 rows this time, so each book only shows up once. So I know that Bodybuilding 10 Minutes a Day is written by Reading Materials Incorporated. Revenge of Mickey is Printing Is Us. Build a Car with Toothpicks is published our way, and so forth and so on. So now I'm seeing these records join properly, join in a way that's more meaningful. It's only going to show a record from the books table, right, where the books or from both the books and publisher. It's only going to join those together if the publisher pub ID is equal to the books pub ID. So they have to share the same pub ID in order for them to show together. So now I can see data from 2 tables, right? You can see how this is important and why this is meaningful. We can combine records from different tables in a meaningful way. So this is one way to do it. There are certainly other ways that we can do this. And of course, I could select additional fields, right? So I could also do, I don't know. Maybe I want to show what the pub ID is, right? So I can add the pub ID. Now, the thing is, if I put pub ID here, there's a problem. And that is that the pub ID appears in both tables, right? It's both in the books table and the publisher table. So I have to tell Oracle which one I'm looking for, right? So I can do this. And then it should show me the record because it knows I'm looking for it in the publisher table. There we go. Now I can see the publisher ID on the side. So you can add additional columns up here. And in fact, if you really wanted to, you could just put a star up here, right? Select all columns from books and publisher and join those together. And I should just get everything, right? So that's all of the columns from both tables where the pub ID is the same in each one. So if I look at all of these records, I should see pub ID. So I got pub ID here. I have a pub ID here. You notice that on each row, they are the same, right? So they're always the same because I've indicated that here. And that gives me a more meaningful way to view this data. Now, there's another way you could do this, and that's using the join keyword, right? So I'm going to do, instead of just doing a select star from books, comma, publisher, I'm going to do select star from books, join publisher on books.pubid equals publisher.pubid. So if I do that, I'm going to get the same results. It works exactly the same way, but this is just a different syntax. I will tell you that this syntax is better. This will work in almost any SQL engine, right? So if you're using MySQL, PostGre, or Microsoft SQL Server, this will generally work using the join keyword. And this is really kind of better form. This is much better form to do it this way. Most DBAs would recommend doing it this way, so it just makes a little more sense to do it this way. And there's also more you can do with the join command as well. Let me see if I can show you an example of that. So let me look through my notes here. So one example I'll show you is the natural join. So if you do a natural join, you don't have to use the on command over here. What it's going to do is the natural join looks for 2 columns in both tables that are the same name, or where you explicitly declared it as a foreign key. So if in the schema if you design your schema and you made pub ID a foreign key to pub ID, which is the primary key on publisher, this join happens automatically. I don't know if this table was done like that or not, and I can't remember if Oracle will just make some assumptions here, but let's see if it works. There we go. So it worked, right? So it did a natural join using the pub ID. And you can see it puts pub ID over here in the front because it knows they're the same in both records. Kind of redundant, I guess, to show it twice. So that's another example. You can use the natural join, then you don't have to tell it which columns to do the join on. So you could certainly do that. Now, of course, you could join more than one table. More than, and I'll show you an example of that. So let me copy and paste something from my notes here. Give me 1 second. And I want to type all this out again. So here we're going to do a select. We're going to select some columns from the customers table, the orders table, the order items table, and the books table, right? So we have 1, 2, 3, 4 tables here, right? That's a lot of tables. This is where we define the join, right? So we're going to say the customer table, customer number, from the orders table, customer number, right? The customer number is the foreign key. Then we need another parameter, right? We can't just use one because we still have these other tables over here. If I just left it like this, right? If I only did the first 3 lines and I didn't add these additional parameters, then it would do a Cartesian join to these other 2 tables, which of course we wouldn't want, right? So once we have the customer number, right? The customer and the orders, then the order items. We're going to get the order items with the second and that you see here. And then we're going to get the books with the last join that you see here on the bottom. Because the order item is going to contain an ISBN, and then the books has the ISBN so we can show that title. So we're showing, basically what we're doing is we're showing all of the last names and first names and the title of the book that those customers have ordered. So I should see customers listed multiple times, right? The way this join works, it's not going to be just one customer. It's going to be the customer's last name and first name for each book that they bought. Let's see if it works. I'm going to run this and see what it does. Oh, you know what? I got a syntax error here. That minus should be an equal. Let's see if that works. All right, here we go. So we've got the book that was ordered by each one of these customers, right? And you can see that some customers show up multiple times because they ordered several books, right? So Leela Smith ordered both E-Business the Easy Way and Painless Child Rearing, and so forth. I can't see any other multiples in here. I'm sure there's other ones that show up twice, but yeah, Benita Smith is in here a few times. She ordered a couple different books. Database implementation and cooking with mushrooms, for example. So I was able to select from multiple tables. And of course, just like any other SQL statement, you can add other things like the order by clause, right? So I could do order by last name, first name. So this will be a little bit easier for us to see the duplicates, right? Because we'll order it by name. There we go. Now we can see that Tammy Gianna ordered a whole bunch of books, and Gerard ordered a couple of books, and Benita Morales ordered a bunch of books, right? They're all mixed up before, now they're ordered. So the order by still works, right? All of the other things that we've talked about still work. Everything that you've learned so far will work, even with the even when you're joining tables together. So I already talked about the natural join. Let's see, what else do I need to do? I'll just do another syntax for join. So let me copy this from my notes. So another example. So here we're going to select the title, the publisher ID, and the name of the publisher, right? So the title of the book, the name of the publisher ID, just so we can see they're the same. We're going to do the same thing, right? We're going to do a join, but instead of now, normally we would do, on pub ID equals pub ID, right? So book, it would look something like this. Join books on, oops, that should be B. On B dot pub ID equals P dot pub ID. This is how we did it before, right? But now, instead of doing that, we know that the pub ID is the same on both tables. So we could just tell it to join it using pub ID, right? So a little bit like the natural join, same concept, right? If we have the same column name in both tables, then we can just use the using keyword. This is one of those things that works in Oracle, but I don't think this works in other database engines. It might work in some, but it's not universally supported. So again, using that full join syntax where you explicitly indicate which columns is definitely a little bit better. And I do that for everything just because I like to get used to doing it in a way that I know is going to work in almost any database engine. So that's another way we could do it. We can use the using keyword since they both have the same, they both share the same column name. Of course, if they didn't share the same column name, that would not work. All right, so let's look at a different example. So you can do joins. When you use the old-fashioned method, we can do a join that's a little more complicated. Here, we're going to show all of the titles and the promotional gift. Right, you get a promotional gift if you in certain circumstances. We're going to show that where the retail cost of the book is between minimum retail and maximum retail for promotional gifts. And this is going to show us a list of all of the promotional gifts that you might get. Right? So here we can see that if you buy Big Bear and Little Dove, you get a bookmark. If you buy Cooking with Mushrooms, you get book labels. Right? If you buy Holy Grail of Oracle, you get free shipping. So this shows me the gifts, right? Because if we look at the, this will probably make a little more sense if I show you the table. So let's do select star from promotion. I have a little M there, but it'll still work. All right, so here's our promotions table. So if they if the retail cost of the book is between 0 and 12, they get a bookmark. If it's between 12 and 25, they get book labels. If it's from 25 to 56, you get a book cover. And if you spend over $56, you get free shipping. Although I don't know why they cut that off at $1,000. I guess they just thought that nobody would spend over $1,000. But in any event, this is the range of what you have to spend. So if we get the retail cost of the book, right here we're doing we're selecting where the retail cost of the book is between the minimum and maximum retail. So wherever, if that retail falls between 12 and 25, it's going to show book labels, right? And it just so happens that we only get one result here, right? Because it's always going to be between one of these sets. But what if I had multiple gifts in these different ranges, right? Maybe they're even overlapping ranges. Then I might see the same book show up 3 times with 3 different gifts if it falls into several different ranges. So it's kind of a hybrid of a Cartesian join. And that would probably work. We could do the exact same thing, right? So I did that the old-fashioned way, the old way with Oracle, but we can also do it the new way. In fact, instead of getting rid of this, I'll just add it to this. Let me make this bigger so you can see it. So this is how we do it with a join, right? Same exact thing. We're essentially doing the same thing, but instead of using a where clause, we use a join clause to put it together. So if I do that, we get the same result, right? Works the same way. Now you might be asking yourself, why, what's the difference between these two? Well, functionally, they both work the same way, right? They're both going to give us the same result. I don't really think there's any performance difference between the two in Oracle, at least in most cases. It still has to do the same work to figure out what, the equality between those two columns. But structurally speaking, it's better to do it with the join clause, because if you need to use a where clause later on, it's better if you keep the two separated for a variety of reasons. So it is good to get in the habit of using the join. So I kind of talked about 2 reasons that it's preferable to use join. Number 1, the other method doesn't always work in every database engine. And number 2, if you use the join clause, you're not going to be using the where clause for both joining the tables and for doing some restriction on the rows. So if you wanted to add a complicated where clause that is looking for very specific things in that table, you wouldn't want to have to worry about mixing up both the logic for joining the tables and the logic for restricting the rows. And you can also use SQL hints, which we haven't talked about in this class, but makes it a little bit easier to use hints when you're using the join separate from the where clause. So a couple of different reasons why we'd want to do that. So let me see if there's something else that I could tell you about a join. So here's another problem we have with selecting from multiple tables. Let me give you an example here. Let's see. I'm looking at our tables here on my other screen. So if I select star from customers, then I'm going to do a select star from orders, right? So you have 2 tables. We have, oh, that's right. We have to do these separately. So we've got a list of customers, right? So here's all my customers. We have a whole bunch of customers in our system, which is great. You know, we want lots of customers. And we also have a nice list of orders. So let's take a look at our orders. So here's all of our orders, and it references the customer number, right? So we know we have a customer number. So if I wanted to, I could join these. So I'm going to select star from customer and orders. And I'm actually, you know, I'm going to use the join method. I just told you that's better, so let's do that. So we're going to join orders on orders.customer number equals customer.customer number. Now, before I do that, oh, it's okay. We can just run this. All right, so we're going to select all the columns from both customers and orders. We're going to join it where the orders customer number is equal to the customer number, right? That's going to be our classic join. And let's see how many results we get. We get 0 results because apparently it's customers. Sorry. Let's try this again. There we go. All right, so we've got quite a few. And by the way, I'm just going to put a carriage turn here so it's easier to read it. Okay, so we have in our result list here, we've got 21 rows returned, right? So 21 orders came back. Now, obviously, all of these customers have placed an order. But think about this for a second. What about my customers that didn't place an order? If a customer didn't place an order, I'm not going to see them in this list because they didn't place an order. They're not equal, right? There's no, that customer number, since it doesn't exist in the orders table, it's never going to show up in this joined, in the statement that joins these two together because there's never a scenario where they're the same. So what if I want to tell Oracle, I want to select all of my customers and then show the orders. So if they don't have an order, still show the customer, right? That's pretty common. Maybe you want to get a customer list and show their orders, but you also want to show customers that didn't order anything. You still want to see that. It's still meaningful in that customer list. You just happen to want to also see all of their orders. So with Oracle or with any database engine, the way you do this is you do a left join. So this is called an outer join. By the way, if you don't do a left or a right outer join, it's implicitly an inner join. Inner join means only show where the records exist in both tables. An outer join means show records in one of the tables first and then join to the other table. So you still see them even if they don't exist. So left versus right, let me explain what that means. When you do a left join, it joins to the table to the left of the join clause, right? So it starts with the table on the left, and then it includes everything that's on the right that matches. If you do a right outer join, it reverses that. So if I did a right outer join, it's going to get everything from orders and then only show matching customers. Now, of course, that would never happen here, right? We probably would never have an order with no customer because I think you have to have that foreign key. It's a constraint in our database. But let's see what happens. So this first time we got 21 rows. I'm going to run this again. Hopefully I typed it right. And this time we have 27 rows. And you can see we've got a whole batch of rows here. So, for example, Michelle Daum did not order anything. So it's just a bunch of nulls over here. So for the order number and the order date and the ship date, those are all null because they didn't order anything. But at least they show up in the list, right? So we still see those customers even though they didn't actually order anything. So that is a left join. Okay, so again, you can do a left join, you can use a right join. And because this is customer number, I could have done it like this as well, right? I could have used the using clause. Using, oh, whoops, it's lowercase, I think. Using customer number, that should work. Let's see if it works. Oh, that doesn't work. I would think that would work. Left outer join. Oh, I forgot. You don't want to have the on keyword there, right? It's just left join orders using customer number. Let's see if that works. There we go. So same results. So I could have just used using. So everything else remains the same. We just add this left outer to the front. And like I said, if you used right, it would just do it the other way around. It just depends on how you did that join. Some people just use left join because they always write their statements where they always know the left side is going to have the table that they're looking for all the records. But you can do it either way. You can either use a left join or a right join, and it just reverses which table has all the records. So that is a left join. So let me see what else we need to talk about in this unit. All right, so another keyword we need to cover is the union. So for example, if I am, so here's a kind of a complicated query, right? Not that complicated, but we're going to show the author ID from the books table. We're going to join book author using the ISBN. So we're going to get both book and book author joined using ISBN, where the category, which appears in one of those tables, is equal to family life. So that's going to give me a list of all of the authors that wrote a book about that's in the category of family life. Now let's say I also had a query to get all of the same books, but this time where the category is children, right? I want to see all of the, oops, let me move this down so you can see this. So now I'm going to show all of the books that are written by all the authors that wrote a book about children, right? There we go. So I've got 2 authors that wrote a children's book, or a book, maybe not a children's book, that maybe just be a book about children, I don't know. But in any event, if I try to run both of these with Application Express, we know that that doesn't really work, right? Application Express blows up if you do that. But we can work around that by using the union command. When I use a union, it's going to take all the records in the first data set, and it's going to then select everything in the second data set and put it together as one giant table. So let's run this. There we go. So now we have all of the authors that wrote a book about either family life or children. Now this isn't the greatest example because theoretically I could have done down here, I could have just added in the where clause where the category is equal to family life or category is equal to children, or I could have done category in family life, comma, children, parenthetically, right? So there's a couple different ways I could have done this, but just as an example, you know, and this is great when you have really complicated queries against 2 different tables that you need to show them together for some reason. You could use this syntax. There's a similar command, so that's a union. And another example is the intersect command. So for example, if I just select customers from, customer number from customers or customer number from orders, right? So this will show me all of my customers, right? So I'll have 27 records here, or 20 records rather. And then if I do select customer number from orders, I've got, my 21 orders that have been placed. But if I intersect these two, it's only going to show me where the customer number is in both, right? So now I can see a list. These are all my customer numbers that actually placed an order. So 14 customers placed an order. So intersect just shows you where the results intersect. Now in this example, I'm only showing you one column, but you could have multiple columns in both of those select statements. But whether it's a union or an intersect, in both scenarios, whether it's a union or intersect, you must have the exact same columns. I'm sorry, not the same columns, but the same data types, right? So customer number happens to be an integer. So we're selecting an integer in both of, just one integer in one column. I could have multiple columns, right? I could do customer number and last name and then first name. And then for the intersect to orders, I could do customer number and then 2 other fields that happen to also be varchar, right? Because they're all varchar 2 or nvarchar 2. I could do that. That wouldn't be meaningful here, but I could do that. But if I tried to select maybe a date in the first select statement as my second parameter, and then a varchar is the second parameter on the second statement, that would fail because all of the columns must be aligned the same way, right? You have to have all the same data types in the same order and the same number of columns. If you violate that, then the intersect or the union will fail, as will a minus. So minus is kind of similar, but this is a little bit different. This is going to take the results from the customers and it's going to subtract the ones from orders. So this is just going to give us a list of the people that have not placed orders. So we have 6 customers that have not placed an order, which as a sanity check, we know that's true because we saw about 6 records in that left outer join that we did earlier. So a minus, right, it's going to take the records from the first data set and then it's going to subtract all the results from the second data set. So it's saying, give me everything in this top table where I don't have matching records in the second table, in the second set. And of course, there are more than one ways to skin a cat, right? So when you do your homework assignment and it asks you to use these commands to find something, theoretically, you could give me a different command that answers this same question. You could say select customer number from customers where customer number not in select customer number from orders, right? You could do that and it would be essentially the exact same thing, but this is how you would do it with the minus command. So it's just a different way to do it. So I told you about the union command, the intersect command, and the minus command. That's how we combine or take multiple data sets and combine them in different ways. And then speaking of combining, right, we also talked about doing a join. The only thing I didn't show you how to do, which I feel like I should show you how to do, is if you are going to do an outer join with the wait, let me just show you here. So let me bring over another one from my notes here. So let's say you're going to select the last name and first name from customers as well as their order number, right? And then we're going to do that from customers and orders. Normally, if you're going to use this method, right, if we were using join here, we would just do a regular join, but I'm going to show you doing where clause. We've been doing this all along, so we'll do C dot customer number equals O dot customer number. Right, so this should show us, and we kind of did this before, right? So we're showing the last name and the first name from both tables, and of course we have 21 rows, but I'm missing all of those customers that did not place an order, right? So I'm not seeing all the customers that didn't place an order. So how do I do that outer join? You can't do a left outer where, right? So there must be another way to do this, and there is. All you have to do is you put a plus after the table that you want to include all the records. So if I put a plus next to the customer side, I think I remember doing this, right? Make sure I got the syntax right here. So now I've got my there's only 21 rows here. This should work. So if I put a plus here, I should see all of the customer records, and then it's going to join to the orders table. Let me check though. Oh, sorry. You know what? Now that I think about this, I got it backwards, right? It should be, I want to show all the orders. So let me get rid of this. And the customers. There we go. So this shows all the customers, and then it adds the orders to it. So it's a little different, but as I said before, the join for me, I think the join's a lot easier. It's a little bit more obvious. It's easier to work with it. I would recommend using the join method. So this is equivalent to a outer join, what I did here. I don't want to say a left or a right because it could be either one depending on how you write that statement, right? How you write that join. If I join from orders first, it would be a right outer join. If I join from customers first, then it would be a left outer join. But in any event, this is how you would do an outer join using the where clause method. So I showed you how to do joins. We talked about Cartesian joins, which is the same as a cross join in Oracle, which really just means multiply all the records. But then we could keep it from multiplying everything by adding a where clause so that it only shows records where there's matching, things that are matching in both tables or 3 tables or 4 tables or how many tables you're joining. Or you can use the join keyword, which is the preferred way to do it, right? So the join keyword is a little bit better. It's a little more efficient. It gives the database engine more information about what you're trying to do. So it's better to use join if you can. And I showed you how to do that and a couple different ways to do that. You could do the on and then 2 column names. You can do on and have a range, right? Any valid Boolean expression will work with a join, just like it would with a where clause. And I also showed you the natural join, which uses the schema because it knows what the foreign key is and how those tables are related. And you can also use the using if the 2 column names are the same when you're doing a join. So that's it for this unit. So that's how you work with selecting from multiple tables at the same time.